Hello everybody, welcome to another video lesson. We are starting a new topic today. That topic is polar coordinates. All right, after today, we're going to kind of figure out what polar coordinates are, and then we're going to use that new information of this new topic to graph points within our polar coordinate system. And then we're even going to graph very simple polar equations. All right, so let's hop right into it with our concept slides. First thing is, what is a polar coordinate? What are polar coordinates? And we're going to start off by likening these to our rectangular coordinate system and kind of comparing them a little bit. So our rectangular coordinate system, we often think of our XY axes, right? Okay, or our horizontal, vertical axes as well, okay? So if I have a point that I want to graph, 0.32, you guys know that we would go along the horizontal axis at 3 points, and then we'd go, or 3 units rather, and then we'd go up the vertical axis 2 units, right? And that would be our point right there, 3,2. Okay, you guys have done that for quite a few years now. So, and we're doing this about this point right here, right? Our origin, okay? We're doing all this movement from the origin, right? We're moving this way, and then we're moving this way. This kind of tells us where to start when we start moving, all right? So now for our polar coordinate system, we have something very similar. We do have an origin, except instead of calling it the origin, we are going to refer to this as the pole, okay? This pole is our starting point for our polar coordinate system. And we have something very similar to our horizontal axis, or a positive horizontal axis, and that is called the polar axis. All right, so the polar axis is kind of where we start all of our rotations. All right, this is our like reference point, right? Our horizontal, as we're knowing, our horizontal as we are used to calling it for our rectangular coordinate system. We're calling that our polar axis now. Okay, so when we go ahead and graph points, points are going to be identified by what we call polar coordinates, and those coordinates have values and they're denoted as r theta, okay? So instead of xy, we now have r theta, and you're probably asking, what is that? Well, if I have a point, okay, that I'm graphing in my polar coordinate system, okay, r is going to be the distance from the pole to that point, okay? The direct distance from the pole is what r is, okay? To that point. So say this point right here is our little sample point here. Okay, and then theta is going to be the angle from our polar axis. All right, so distance from the pole and then angle from the polar axis. That is what we're working with r and theta. Okay, so we got to kind of shift our mindset from x and y. Now we're thinking r and theta, which is kind of like distance and then rotation. Okay. Alrighty, let's get into some polar equations now. Okay, the definition of a polar equation, it's really just an equation in terms of polar coordinates, r and theta. All right, so a very simple example would be r equals cosine theta. Okay, and to graph one of these, or a polar graph, would be a set of all points that satisfy a polar equation. Now notice I highlighted all, okay, because what you typically get with these, and not always, but often, okay, when we graph a polar graph, we get this kind of closed system here, okay? So it starts to repeat itself right after a while, and we'll get to this kind of plane. I guess we can talk about this plane now. So this is our polar coordinate plane. As you can see, it almost looks like a unit circle, right? Almost, okay? But what we're seeing here is we have different, each one of these rings is a new r value, right? Because we're getting further and further from the pole right here, okay? So as we get further and further from the pole, our r value gets bigger. So you can see here we have an r value of 0.5, and then we keep going and we have an r value of 1. Now, so that's moving out from the pole. So now this would be our polar axis right here. Okay, so as we move around the polar axis, notice this is what kind of looks like a unit circle, right? I've got all these angles here that we're kind of used to seeing with our unit circle, and those would be the angles that you would plug into your polar equation, okay? Now we're going to graph even simpler polar equations than this one today, but this is what we're graphing on at this point, okay? this whole chapter, we're going to be working with this polar coordinate system and this polar coordinate plane that's going to look just like this. All right. So again, working from the pole outward, that is where our R values are increasing. So from here we have 0.5, but also we have 0.5 here, 0.5 here, 0.5 here. That's because that R value is the same around this whole ring right here. That is 0.5. All right. And then as I move out even further, I've got an R value of 1, 1, 1, and 1. That's because we're going around the pole in this circle of an R value of 1. All right. And then we have different angles, and these angles are referring to this polar axis right here, which you might think of as the positive horizontal axis. Okay. But in this case, it is now our polar axis. That is our starting reference point. Okay. So now let's take a look at one last thing I want to show you guys. That is our polar distance formula. Okay, so if I have 2 points here, I've got point P1 and P2. Okay, and we want to find the distance between them. Now P1 and P2 have polar coordinates, but I want to think of these as Cartesian coordinates just for a little bit. Okay, so I'm going to say P1 instead of R1 theta 1. If you remember how we kind of found like vectors, right, and put those in component form, right, we would say R1 cosine theta 1 and R1 sine theta 1. There should be a 1 right here, right? Okay, and that would be referencing again, that cosine theta 1 and sine theta 1 would be referencing the angle that this first point makes when I go from the pole straight out to that point, okay? And then for P2, I'm going to write that as R2 cosine theta 2 and R2 sine theta 2, okay? So again, just putting these in terms of our Cartesian coordinates, and we're going to go ahead and write out our distance formula. All right, so this would be change in x, okay, or difference in x squared, quantity squared. So I'd have R2 cosine theta 2 minus R1 cosine theta 1, that whole quantity squared, and then plus R2 sine theta 2 minus R1 sine theta 1, that whole quantity squared, and we take the square root of that whole thing. And that is our distance formula that you're used to seeing in the Cartesian coordinate plane. Okay, we just have a little bit longer values here instead of x's and y's, all right? So if we went ahead and expanded these terms that are being squared here, all right, we would have this whole long thing here. So I got R2 squared cosine squared theta 2 minus 2R1 R2 cosine theta 1 cosine theta 2 plus R1 squared cosine theta 1 squared. Okay, that is this whole thing from here to here, okay, is just this first expression being squared. Okay, this whole thing being squared, I've just expanded it, and that's what that looks like. Okay, and then again, I'm doing the same thing here. This is going to be this second term, or these two terms, the difference of these terms, squared, just expanding it, all right, which we've done many, many times before. Okay, so now we are going to head and start grouping these so we can start simplifying. So if I go ahead and group these two terms here, hopefully you notice that they both have a cosine squared theta 2 and sine squared theta 2. Now I want to group those because if I were to factor out R2 squared, then I have cosine squared theta plus sine squared theta. So that's great. We can use that to start simplifying. So again, over here with our theta 1s, I've got two similar terms here that I can do the same thing with. I'm going to factor out R1 squared, and that's going to leave me with the cosine squared plus sine squared in there. And then here I've got these two terms where I have a 2R1 R2 in here. So if I go ahead and bring those together and then factor them out, all right, kind of group those and factor them, then I'd factor out that 2R1 R2, and what's left in here, I've got cosine theta 1, cosine theta 2, plus sine theta 1, sine theta 2. Now, we can start canceling. Hopefully you easily see that what we have in these first two parentheses just equal 1, which is great. And then this one here is also a pretty new, not formula, this is a pretty new property that we worked with a couple units ago. So this is going to be the difference of angles here. Okay, this is the difference of angles for cosine. All right, so this thing simplifies to cosine theta 2 minus theta 1. All All right, so that is how we derive our polar distance formula of the square root of r1 squared plus r2 squared minus 2r1 r2 times cosine theta 2 minus theta 1. All right, so that is a lot there. Make sure you get that written down because we are going to use this today and moving forward. All right, that is all for our concepts. Let's get into some examples quickly. All right, we're going to graph some points here. Okay, so I've got point D. Point D is -1, has polar coordinates -1 pi over 2. Okay, so we're going to go from our polar axis. We're going to rotate positive, because this is positive pi over 2, so we're going to rotate counterclockwise, okay, pi over 2. All right, now what this tells me is that this is my positive axis right here, okay, that I'd be working on. Okay, this would be the positive direction, rather. Right? But notice here that my R value is negative, so instead of going up this way, I'm going to go down the opposite way. Okay, kind of like when we were working with vectors, right? We had opposite vectors, they just went 180 degrees the other way. Okay, so we would plot point D here. If I plot point D, okay, that's a D. And that would have a distance here of 1 unit, whatever my units are. Okay, so that's kind of the premise here of graphing these points here as our coordinate points. Okay, so again here I've got point E. It's got coordinate points 2.5, 240 degrees. So I'm going to start again from the polar axis and I'm going to rotate counterclockwise 240 degrees. Okay, this is just a rough estimate here. And then I'm going to go out 2.5 units. All right, and that is how I would graph point E. Point E. All right, that is an E. Sorry, bad handwriting. All right, lastly, we've got F here. Notice my angle is negative, so I'm going to start at my polar axis again, but this time I'm going to rotate clockwise. Okay, so I rotate clockwise, -5 pi over 6. All right, and then again, I just go out 4 units, whatever that is, and that would be how I plot point F. So that is graphing some points here. Now let's go ahead and take a look at our polar grids. Okay, so graphing on our polar grids now. Okay, same thing. Now, again, this is where we're starting from. This is our positive horizontal axis is what it looks like, but this is our polar axis rather. Okay, so this being our polar axis and this center point being the pole, all right, that's what we're looking at here with our polar grid. So I'm just going to rotate -7 pi over 6. That's going to land me right about here. Okay, and then I'm going to go out 1.5. Okay, so this is where my point R would be, R 1.5, -7 pi over 6, right? So go ahead and pause the video since I've been graphing all these so far. You guys try to graph point S here with points -2, or with coordinates rather, -2, -135 degrees. Alrighty, hopefully this is what your graph looks like. Okay, if you just sketched it, that's fine. I know these things are kind of hard to draw out sometimes. So this is roughly where you would be. Again, we're going -35, but now we got -2 for our R value, so we're going to go the opposite way 2 units. Okay. Now, looking at multiple representations. Okay, what would happen? I've got this point right here, and yes, -2, -135 degrees lands us at this point, right? But what happens if I were to subtract another 180 degrees? Well, can you see that we just land at that exact same point? Yeah. Now notice here when we do that though, I still have an R value of 2, but now it's +2. Okay. So when I add or subtract 180 degrees, my R value changes and I actually just land on the same spot. Okay. So again, if I have -135 and I were to add 180 degrees, okay, now I have an angle of 45, but my R value now is 2 instead of -2. Okay, so that is when we add or subtract by -180 degrees, our R value changes signs only, and then our angle changes by that 180 degrees that we added or subtracted. And similarly, if I were to start here at our -135 degrees and I were to add 160 degrees, okay, so I'm going all the way around the pole, a whole revolution, all right, I end up at this same sort of reference direction, right? However, in order to get to this same point here, I would then have to go -2 again, Okay, so if I add or subtract 360 degrees, now my R value actually stays the same and my angle is the only thing that changes. Okay, so with that in mind, you guys go ahead and try to find 3 points of polar coordinates that name the given point within the interval. So you have our point 2 pi over 6, okay? That is our point, all right? R value of 2, theta of pi over 6, okay? Within the interval, negative 2 pi to 2 pi, see if you can find 3 pairs of polar coordinates that land you on this same point, okay? Pause the video and see if you can't find that out. Alrighty, hopefully you got 2, negative 11 pi over 6, negative 2, negative 5 pi over 6, and negative 2, 7 pi over 6, okay? And this is kind of what I was doing with my angles and rotations, all right? And this was my original point right here. All right, now we're going to graph very simple polar equations, okay? We've got r equals 1.5, and we've got theta equals 5 pi over 6, okay? So for this first one, r equals 1.5. Let's think, okay, what does this mean? This means no matter what the angle is, it does not matter what theta is, okay? All points are 1.5 units from the pole, okay? So if I start graphing this out, thinking about this, okay, if I have an angle of 0, I go out 1.5, I end up right here. Well, what about an angle of 60? Okay, again, I go out 1.5. If I've got an angle of 150 degrees, again, I'm going to go out 1.5, and I just rotate 150. Okay, 270, again, I just go out 1.5. So what does this actually give me as far as my polar grid goes? It gives me what looks like a circle, okay? So r equals some value is just having the same distance from the pole the whole time around, okay, no matter the angle. So it's going to give me a circle on my polar grid. Now, it's a little bit different with theta equals some constant, okay? So what this is saying is that no matter the distance from the pole, okay, no matter what my r value is, the angle is always 5 pi over 6, okay? So I've got a couple points here, 2 5 pi over 6 and 1 5 pi over 6, right? So I'm starting here at my polar axis, rotating 5 pi over 6. I go out 2, I can go out 1, but what about if I go out negative 1, right? Okay, negative 1 5 pi over 6 lands me over here. And what about 0? What about the pole right here? Okay, the pole is actually any point that has an r value of 0. Okay, so keep that in mind. That's very important to understand. Any coordinate pair with a r value of 0, that's automatically, it's just on the pole. Okay, just on the pole there. So it doesn't matter what the angle is. That's going to land you right on the pole. Okay, so what this actually looks like is going to be a straight line kind of cutting through the pole, all right, going out infinitely in either direction because the r values, again, can just keep getting larger, 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 and more negative, more negative, more negative, and so that's going to look like a straight line for us, okay? All right, last example here, we've got an application, all right? We've got a naval radar that is tracking 2 aircraft carriers. Okay, the coordinates of the 2 carriers are going to be 8, 150 degrees, and 365 degrees. Okay, R is measured in miles. That is important to keep in mind what our units are. Okay, so we've got 2 things to do. First, we want to sketch this whole situation. So we've got our polar coordinate grid here. All right, we can just go ahead and plot these points out. Okay, so for our first one, we're going to start at starting at our polar axis. We're going to rotate counterclockwise 150 degrees, okay, right here. And then we're going to go out 8 units here. Okay, so notice I got 5, 10, so I'm going to be right here at 8. Okay, and then likewise for our 365, okay, rotate 65, that's roughly 65 right there. And we're going to go out 1, 2, and 3 units for our R value, right? So now part B, what is the distance between the 2 aircraft carriers? We're just going to use our distance formula here, okay, that we derived earlier in our concept slides. And it doesn't matter what I assign as 0.1 or 0.2, okay, just make sure you keep them consistent, all right? If I name this one R1, but then I start to use it sometimes as R2 in my formula, that's when it's going to get messed up, okay, and you're going to get the incorrect answer. So let's go ahead and just plug in our values here. So I've got 8 miles, okay, 8 miles squared for R1, and then I've got 3 miles squared, that's our R2 squared. minus 2 times 8 miles times 3 miles times cosine of 65 degrees minus 150 degrees. Now notice here units-wise, okay? R is measured in miles, which means this distance right here, this is what we're trying to find, guys. Let's see if I can get a straight line going right there. Okay, this distance is what we were trying to find, right? That distance better be in miles when I do this distance formula, right? Otherwise, I have done something wrong. However, we can see here that all of these have units of miles squared. So when I go ahead and take the square root, I'm going to get miles, which is going to give me a correct answer. Good. Okay, so I've just started to simplify this here. We can plug this directly into a calculator, and we can see that they are about 8.3 miles apart. All right. So that is it, guys. That's our introduction to polar coordinates and a little bit of practice there for polar coordinates in the polar coordinate grid. Lots of P's in there. All right, so good luck with everything, guys. Good luck with your practice.